8202. Why are aluminum plates 1/4 inch or more thick usually preheated before welding? A. Reduces internal stresses and assures more complete penetration. B. Reduces welding time. C. Prevents corrosion and ensures proper distribution of flux. The correct answer is A. Aluminum plates 1/4 inch or more thick are usually preheated before welding to reduce internal stresses and ensure more complete penetration. Preheating involves heating the base metal to a specific temperature range prior to welding. In the case of thicker aluminum plates, preheating is beneficial for several reasons. Firstly, aluminum has a high thermal conductivity, which means that heat dissipates quickly, making it challenging to achieve sufficient penetration during welding. Preheating the plate raises its temperature, allowing the heat from the welding process to be more effectively transferred to the workpiece, promoting better fusion and penetration. Secondly, preheating helps reduce the risk of cracking and distortion. Aluminum has a high coefficient of thermal expansion, meaning it expands and contracts significantly with temperature changes. By preheating the plate, the temperature difference between the base metal and the welding heat is reduced, minimizing thermal stresses that can lead to cracking or distortion. Lastly, preheating can also assist in the removal of moisture and other contaminants from the surface of the aluminum, improving the quality of the weld and reducing the risk of defects. Overall, preheating thick aluminum plates before welding helps ensure a successful and high-quality weld by reducing internal stresses, promoting better fusion, and minimizing the risk of cracking and distortion. 8203. How should a welding torch flame be adjusted to weld stainless steel? A. Slightly carburizing. B. Slightly oxidizing. C. Neutral. The correct answer is A. When welding stainless steel, it is recommended to use a slightly carburizing flame, which means a flame with a slight excess of acetylene. The flame should be adjusted in such a way that a feather, approximately 1/16 inch long, forms around the inner cone. This feather is created by the excess acetylene in the flame. 8204. Oxides form very rapidly when alloys or metals are hot. It is important, therefore, when welding aluminum to use A. Solvent. B. Filler. C. Flux. The correct answer is C. When aluminum is heated during the welding process, it quickly forms an oxide layer on its surface due to its affinity for oxygen. This oxide layer can interfere with the formation of a strong weld and hinder the flow of filler metal. To prevent or minimize the formation of oxides, a flux is used in aluminum welding. Flux is a chemical compound that helps to clean the surface of the metal by removing oxides, dirt, and other contaminants. It also creates a protective barrier that shields the molten metal from the surrounding atmosphere, preventing further oxidation. By applying a flux during aluminum welding, the oxides are effectively dissolved or removed, allowing for better wetting and adhesion of the filler metal to the base metal. This promotes a stronger and more reliable weld joint. It's important to note that different types of fluxes are available for aluminum welding, including both corrosive and non-corrosive varieties. The specific flux used may depend on the welding method, application, and personal preference. 8205. In gas welding, the amount of heat applied to the material being welded is controlled by the A. Oxygen acetylene regulator. B. Size of the tip opening. C. Cutting oxygen valve lever. The correct answer is B. In gas welding, the flame temperature is determined by the ratio of oxygen to acetylene in the welding torch. However, controlling the flame size and, consequently, the amount of heat applied to the material is achieved by adjusting the tip opening. By changing the size of the tip opening, the flow rate of the gases can be regulated, resulting in a larger or smaller flame. A larger tip opening allows more gas to flow, resulting in a larger flame with higher heat output. Conversely, a smaller tip opening restricts the gas flow, resulting in a smaller flame and lower heat output. By adjusting the tip opening, welders can control the heat input to the material being welded. This is crucial to achieve the desired welding temperature and prevent overheating or underheating of the workpiece. While the oxygen acetylene regulator and cutting oxygen valve lever are essential components of the gas welding setup, they primarily control the gas flow and pressure, not the amount of heat applied to the material. 8205-1. When welding or cutting, the acetylene pressure gauge should never be set higher than A. 15 psi, B. 20 psi, C. 25 psi. The correct answer is A. Acetylene is a highly flammable gas that can become unstable and prone to decomposition at high pressures. To ensure safety during welding or cutting operations, it is important to adhere to the recommended maximum pressure for acetylene. The standard industry practice is to limit the acetylene pressure to 15 psi, pounds per square inch, or lower. Operating at higher pressures increases the risk of a gas cylinder or equipment failure, which can lead to hazardous situations such as leaks, explosions, or fires. By keeping the acetylene pressure at or below the specified limit, welders and operators can maintain a safe working environment while effectively carrying out their welding or cutting tasks.